Program development. The mechanics of developing a program include several activities: writing a program in a specific programming language, translating the program into a form that the computer can execute, investigating and fixing various types of errors that can occur. Software tools can be used to help with all these parts. Language levels. There are 4 programming language levels. There's machine language, assembly language, high-level language, and 4th generation language. Each type of CPU has its own specific machine language. The other levels were created to make it easier for a human being to read and write programs. Each type of CPU executes only a particular machine language. A program must be translated into machine language before it can be executed. A compiler is a software tool which translates source code into a specific target language. Sometimes the target language is the machine language for the particular CPU type. The Java approach is somewhat different. So in Java, our compiled program is actually bytecode that is targeted for the JRE. The Java compiler translates Java source code into a special representation called bytecode. The Java bytecode is not machine language for any traditional CPU. Bytecode is executed by the Java virtual machine. Therefore, Java bytecode is not tied to any particular machine. Java is considered to be architecture neutral, and that's what makes it so popular. That's why it became a really popular language, because when you write Java code, you're not targeting any specific machine. So here's a diagram for what we're doing. The Java source code is what we're going to write. We're going to use a Java compiler. If we successfully compile a Java program, meaning the syntax of your source code is all correct, we're going to produce the bytecode. That bytecode is the .class file that gets generated. That .class file is then able to be read by our Java virtual machine. Before we continue any further, I wanted to give an example of creating a Java program. So I already went ahead and created a file called about.me, and I saved it. So about.me.java. So the first thing we're going to do is we're going to write our class header. So public class and the name of our class. The name of our class has to match the name of our file. So since my file is named about me, my class is going to be named about me. Then I'm going to do the open and close curly brace to open my class and to close my class. And then inside of my class, I'm going to put my main method. Now remember, the main method is the entry point for the Java virtual machine. So whenever we run our program, it's going to look for the main method to start the program. So the main method, the header for this is public static void main, and then string array arguments. Open and close our method. And then I'm going to just print a couple of things out to the console. So I'm going to say system.out.println. And I'm going to just label some of this information. And I'm going to just copy this line and I'll say, just print on a hobby. My hobby is programming. Okay, so I want to open the folder containing this file in command prompt. But before I do that, I want to make a syntax error just to give an example of what would happen. So I'm going to go and just remove this semicolon at the end of line 4. I'm going to hit save. And then I'm going to come over here and I'm going to go to open containing folder. And then I'm going to go to CMD. Okay, so this will open the folder that has my about.me.java. Now I'm going to type the command dir. Now if you're using a Mac, the command to list out what's inside of this folder would be ls-l. Okay, but I am on Windows, so I'm going to type dir. I'm going to press enter. You can see that my Java file is in this folder. So what I'm going to do is I want to compile this Java file. So I'm going to use the command java c about.me.java. I'm going to press enter. Okay, it didn't compile. So when I hit dir again, you can see that only the Java file exists in this folder. Okay, so it didn't compile, it didn't make the bytecode. So if I don't have the bytecode, I can't run the program. The JRE or the virtual machine is going to need that bytecode in order to run your program. So I'm going to come back over here. I'm going to fix my program. I'm going to save it, hop back over to command prompt. I'm going to go ahead and clear the screen, CLS. In Mac, to clear the screen, it's you just type in clear. But in Windows, it's CLS. Press enter. Okay, I'm just going to use the up arrow to find the command to compile that I entered previously, and I'm going to press enter. It did compile, so now when I type dir, you can see that there is this .class file right here. Okay, so that's the bytecode that the Java virtual machine is going to read. Okay, so this is a program that's going to read and run. If you actually look into the folder, and here's the folder containing it. If I try to open this, well, I'm gonna just drag this into Notepad++. If I try to open this, it's just, just these weird characters that's going to be interpreted by the Java virtual machine. So when I hop back over to command prompt, so if I want to run the program, I'm going to enter Java and then the name of the class about me. You don't need the .class at the end of it, so you don't need the file extension. It's just the name of the class, so Java and about me. I'm going to press enter, and then there is my output. There are many programs that support development of Java software, including the Java Development Kit, Eclipse, NetBeans, BlueJ, JGrass. Okay, so I prefer to use Notepad++ on Windows, and on Mac, I prefer to use Sublime Text. It doesn't have as many options and features as Notepad++, but it gets the job done. I'd advise not to use Eclipse or IntelliJ. I think it's overkill for what we need to do for this course. Though the details of these environments differ, the basic compilation and execution process is essentially the same. The syntax rules of a language define how we put together symbols, reserved word, and identifiers to make a valid Java program. The semantics of a program statement define what the statement means, its purpose or role in the program. A program that is syntactically correct is not necessarily logically correct, semantically correct. A program will always do what we tell it to do, but not what we mean. Okay, so what they mean is even though your program compiles and runs, you still need to test your program. That's very important. I get a lot of programs turned in where they think the program is calculating the circumference of a circle correctly, but somehow they messed up the equation and it's not actually doing what they think the program is doing. So it's important to test your programs. Throughout the semester, we'll be writing programs that do various types of calculations, like for instance, maybe the volume of a sphere or the circumference of a circle. Now it's important whenever you create these programs that you actually test these programs. You can use your own calculator, or you can go to Google and Google these equations. When you're testing, make sure you use different values and verify the results against your calculator or against Google. So I'm going to show you how to use Google in order to find some of these equations. It's fairly simple, and you should always do this before you turn your work into me. So when you turn your programs in, consider me as the customer that you're writing the program for. So I should not be the one to test and find your bugs. It's up to you as a programmer to do your own testing and find your own bugs. If you're creating a program for the volume of a sphere, just Google the volume of a sphere. And then when you create your program, just, verify that the results that you get when you type in some value for the radius match what you see on Google. There's all kinds of equations here: volume of the sphere, volume of the cylinder, circumference. So make sure you're doing something to actually test your program and validate the results. A program can have three types of errors. The compiler will find syntax errors and other basic problems. If a compile time error exists, the executable version of the program is not created, so the .class file will not be generated. A problem can occur during the program execution, such as trying to divide by 0, which causes the program to terminate abnormally. That's what we call a runtime error. A program may run but produce incorrect results, perhaps using the incorrect formula, and that is the logical errors. So here's a cycle of basic development. You edit and save a program, compile. If there's no errors, then you execute the program and evaluate the results. Evaluating the results is super important. Students turn in a lot of programs, but they never actually test their programs to validate that they're working correctly or to verify that they're done in accordance with our coding standard. So make sure you take the time out to do that.